Oh, this is the chemistry final exam stoichiometry review. All right, so what you're going to need for this lecture is the final exam review stoichiometry worksheet. So I'm going to work the first 5 and leave the last 4 for you to work so you'll have practice on your own. The answers to these are on the back. So as you work 6 through 9, you can just refer to those and see if you got the answer right. You're gonna need a calculator, and you will need a periodic table ready to go. Okay, so number 1 refers to this chemical equation. You do have to have a balanced chemical equation to do stoichiometry. And this is the main equation that you need to memorize right here. Grams of substance A, then you go to moles of substance A, then moles of substance B, and then you can go to grams of substance B. So question 1 says, how many moles of oxygen gas are used if 5 moles of CO2 is produced? Okay, so how many moles of oxygen gas? So how many moles? And we have 5 moles of CO2. Okay, so we are going from moles to moles. So this is just 2 steps, 2 sets of parentheses. So we start with what we're given, 5 moles of CO2. Put that over 1. We want to go to moles of oxygen. All right, what do I put on the bottom? What unit? We'll go up and to the left. 1 parenthesis, moles of CO2. All right, and where do I get my numbers? Well, they're the stoichiometric coefficients, the coefficients in the chemical equation. So there are 13 moles of O2 used up per 8 moles of CO2 that are made. All right, so in your calculator, you'll do 5 times 13, divide that number by 8, and you'll get 8.125 moles of O2. All right, number 2 says how many moles of water are produced if 50 grams of C4H10 are used. Okay, so 50 grams of C4H10. All right, I'm going to erase what I put under here for question 1. It says how many moles of water. So question mark moles. So we're going from grams of substance A right here. Then we have to go to moles of substance A, and we want to stop at moles of substance B, which is moles of water. So that's going to be 3 sets of parentheses. All right, so you just follow. If you will write this down at the top of your test, just follow that procedure. So we have 50 grams of C4H10. Now I have to go to moles of C4H10 before I can go to moles of water. So we put moles of C4H10. Get rid of grams of C4H10. Now when you have moles and something else as a unit in a parenthesis, the 1 always goes by the moles. Now that's not necessarily true when it's moles and moles, all right? Because those are when you use, that's the stoichiometry, like in number 1. But moles and something else. So grams. Where do I get grams of C4H10? Well, we add it up from the periodic table. That's how many grams are in a mole. So we've got 4 carbons. 4 times 12 is 48, and then 10 hydrogens. 10 times 1, that would make 48 plus 10, which is 58. So we have 58 grams of C4H10. Now we're almost done. We need to go to moles of water. All right, and I need to get rid of up to the left, moles of C4H10. All right, anytime you got moles and moles, that's the stoichiometry. That's where you use the coefficients. The coefficient in front of water is 10. The coefficient in front of C4H10 is 2. So in your calculator, do 50 divided by 58 times 10 divided by 2. All right, so you can do all those. Type in 50 divided by 58, then you'll get an answer there. Then times 10, you'll have an answer, then divided by 2. All right, and when you do that, you can try that along with me, but you'll get 4.31 moles of H2O. All right, let's get rid of this and we'll look at question 3. So question 3 says, how many grams of C4H10 are used if 10 moles of oxygen are used? All right, so we have 10 moles of O2. So write that in. Try not to erase number 2 there. 10 moles of O2. We want to know how many grams of C4H10 are used. So I'm going to put a question mark and grams. All right, start with what we've been given. Now we're going from moles of substance A, moles of oxygen. We've got to then go to moles of C4H10, and then we can get to grams of C4H10. All right, or if you want to call oxygen moles B, start here, and then go to moles of C4H10, then grams of it. It doesn't really matter. You know that you're starting at moles, and you got to go all the way to grams, all right, of a different substance. So we have 10 moles of O2. We need to go 10 moles of O2 to moles of C4H10. So let's put, you want to put with that on top, that unit, because that's what you're going to. We're going to get rid of moles of O2. All right, you're going to use the stoichiometric coefficients here. So the coefficient in front of C4H10 is 2. The coefficient in front of O2 is 13. And then finally, we want to answer the question, grams of C4H10. So let's put that on top. We're going to get rid of moles of C4H10 because that's where we're at in the problem. Remember, if it's moles and anything other than moles, the 1 always goes by the mole. Where do I get how many grams of C4H10 is in a mole? Well, it's added up in the periodic table. Now, we've actually already added that up in problem number 2. We added it up and it was 58, so I don't even have to do any more work here. So in your calculator, do 10 times 2. That's 20, right? Divide that number by 13, and then multiply, since it's on top, by 58, and you'll get 89.2 grams of C4H10. All right, number 4 says how many grams of carbon dioxide are produced if 100 grams of water is produced. Now this is, we're going from grams to grams, so we're going from one end of the equation to the other. So let's write down under the equation what we want. How many grams of carbon dioxide? Okay, so we're trying to get that. And we are wanting to know, we are starting with 100 grams of water. So I'll put 100 grams there. Okay, so let's call water substance A. We got to go through from grams of substance A to moles of substance A, then to moles of substance B, which is carbon dioxide, and then to grams of substance B. So it's 4 sets of parentheses. All right, 100 grams. Then we've got to go to moles of H2O. We're getting rid of grams of H2O, so we put that on the bottom. All right, just ignore that phone. Sorry about that. All right, so the 1 goes by the mole. If we add up H2O on the periodic table, 1 oxygen is 16, 2 hydrogens would be 2, so that is 18. All right, so we've gone from grams of water to moles of water. Now we've got to go to moles of CO2, where the question mark is. So we put that on top, moles of CO2. And what are we getting rid of? Up and to the left, on top, moles of H2O. Now this is stoichiometry. Anytime you're comparing moles to moles, it's stoichiometry. You're using the coefficients. The coefficient in front of CO2 is 8. The coefficient in front of H2O is 10. All right, so in your calculator, you'll do 100, divide that number by 18, take that number and divide it, multiply by 8. Then, actually, I'm so sorry. I got to do one more step. All right. We're at moles of CO2. We've got to go to grams of CO2. All right. So put what you want on top, grams of CO2, and we're getting rid of moles of CO2, up and to the left. Where the 1 goes by the mole, add up CO2 on the periodic table, it's 2 oxygens, so that's 16 times 2 is 32, plus 12, so that would be 44. All right, now we can do it. 100 divided by 18 times 8, hit equal every time after this if you need to. Then divide that number by 10, and then multiply, because it's on top, by 44, and you'll get 195.6 grams. All right, pause the video if you're still writing, and we'll finish up with number 5. Okay, number 5 says that how many liters of oxygen gas are used if 5 liters of water is produced. Now, we're not talking about grams or moles here, we're talking about liters. And when we're talking about volumes, it's Gay-Lussac's law. Gay-Lussac's law allows you to compare volume of one substance to volume of another substance as long as it's gases. Has to be gases. So you can use the stoichiometric coefficients, the 2, the 13, the 8, and the 10, with gases to convert from liters to liters. And a Gay-Lussac's law is always just 2 sets of parentheses. Just going to be 2 because you're going from liters to liters. All right, it says in number 5, how many liters of oxygen gas? So I'm going to put a question mark, liters there. And we have 5 liters of water. So we start with what we've been given, 5 liters of H2O. We want to go to liters of oxygen. We're getting rid of, when I say getting rid of, I mean canceling out. All right, canceling out liters of H2O. And what goes here are the stoichiometric coefficients. So we have 13, and by water we have 10. So it's going to be 5 times 13. That'll give you a number. And then take that number and divide it by 10. All right? And then ultimately it's 5 times 1.3, right? And that's going to be 6.5 liters of O2. So on the final exam, you will only be asked, this is exactly what will be on the final exam in terms of the types of questions. Any type of stoichiometry question that I can ask, all right, except for the stoichiometry used in limiting reactants, which we'll have a sheet on that. But are these types of problems, these 5 problems. If you understand these 5 problems, then you can do what's on the final exam. I want you to work as practice 6, 7, 8, and 9. Check yourself. And if you have problems, right, check your answers here. If you have problems, just post a question on Microsoft Teams and I'll give you a call, video call, and we'll work through it together. Okay, so work stoichiometry worksheet 6 through 10 for practice. And if you need more practice, then go to the textbook problems. All right, from chapter 6. And you have the answers in your final exam packet from all the practice problems and extra practice problems. Right, there'll be practice problems and extra practice problems from chapter 6. You have the answers on your sheet, so you can just work some of those to get more practice. All right, that'll be it, and I will talk to you next video.